All right, guys, we're going to continue on in our notes. And this time, we're kind of building on the skill that we have just talked about. Prior, you've learned about monohybrid crosses. So monohybrid crosses are your traditional 4-box Punnett squares. And those are crosses that really deal with the probability of two parents producing an offspring with a particular set of alleles for just one trait. And so now we're going to extend that thinking and we're going to look at what is called a dihybrid cross, which is doing the same thing, but instead of just looking at one trait, we're going to look at two traits. And so if we take a second and look at our little guinea pig picture over here, so we have two traits that we're kind of studying in this example. One trait is the color of the guinea pig. So you can see one option for coloration is black and one option for coloration is white. And then the second trait that we're going to look at is the length of the hair of the guinea pig. And so one option is short hair and the other option is long hair. And you can kind of read that in the text to the side if you pull out this guinea pig paper. And in fact, you really should go ahead and get that out. We're going to use that as we talk through how to do this. And you're going to try and also check your guinea pig practice questions as we move along before you're released out to do the second worksheet. And so when we start with a dihybrid cross, we have two different traits. We have to figure out what kind of gametes can each of the parents create. And so each gamete, and this is kind of the rule, each gamete has to have a little bit of each trait in it. So the B's stand for the coloring trait, and the L's stand for the length of the guinea pig hair. We have to have a little bit of B and a little bit of L in each of our gametes. And so the easiest way to do that is probably something that you're familiar with, is the FOIL method that you've used in math. And so to figure out what kind of gametes this guinea pig could create, we would take this big B. Some of his gametes are going to have this big B and this big L. And then another one of his gametes are going to have this big B and this second L. And then another one of the gametes is going to have this second big B and an L. And then the last gamete is going to have a big B and this second big L. So we've just distributed, we foiled to see that actually all of this guinea pig's gametes are going to look like this. Over here, we see a similar thing because there's only small b's and there's only small L's. So all of the gametes will have the same combination. So each parent's genotype in a dihybrid cross, so I'm going back up here to this parent genotype. Each parent will have a genotype that is 4 letters, and those letters are the pair of alleles for trait number 1, which in this case are the B's, and the pair of letters that are representing trait number 2, which in this case is represented by the L's. So keep in mind that when we look at dihybrid crosses, the genotype of the parents have to be 4 letters long instead of 2. We saw 2 letters in the genotypes with monohybrid crosses. Now we see 4 because we're looking at 2 different traits in the parent. And so what we've already talked through in doing your dihybrid cross, step 1 is going to be figuring out what kind of gametes can each parent produce given their genotype. And so we already did that by the FOIL method. We looked at, here's the parent genotype, and if I FOIL this genotype, here are the possible gametes that this parent could create. Same thing over here. Here's this parent's genotype, 4 letters, right, representing the 2 different traits. And by FOIL method, here are the gametes that this guinea pig could produce. So step one is always in a dihybrid cross is always going to figure out what kind of gametes can each parent create. Then step two is going to be put your gametes on your axes and cross them. Right? So we did this before. We put gametes on the axes and we crossed them together to see what kind of offspring could be created. We're going to do the same thing. We're going to put gametes on the offspring, or we're going to put gametes on the axes and we're going to cross them to see what kind of offspring could be created. Now, I'm going to give you this little kind of tip down here. We're used to looking at genotypic and phenotypic ratios. Because the cross gets so big, very rarely are you asked to give a genotypic ratio in a dihybrid cross. More common than not, you are actually asked to give a phenotypic. So what do the offspring actually look like? You give a phenotypic ratio frequently. So if you don't already have this little guinea pig sheet nearby, you need to grab it because we're going to work through it together and you're going to pause the video and check your answers as we kind of go. So we've already done the first part of the front page. It's been done for us actually. You have two parents, one that is black short-haired guinea pig, one that is a white long-haired guinea pig. Here are their genotypes. And we have done step one. What kind of gametes are they going to produce? Now, step two is going to be crossing them together. And so if you look at the chart, it's kind of already been done for you. It's been set up for you. Oh, get back up there. Actually, this is working you through. Aha, I get it. You have a parent generation. If you cross these together, you'll notice the only thing that you can create are these genotypes: big B, little b, big L, little l. So this represents what is called the F1 generation, the babies, the possible babies that these two parents could create. So it's already been done for you. There's only one possibility here based on the gametes that mom and dad could create. There's only one possibility for offspring. So the F1s, the babies of these two parents, are going to be heterozygous for both traits. Now, the question set on the front asks you to cross these two, and that will get a little bit trickier. We're going to walk through that process. So step one would have been figure out the gametes that this organism could create and figure out the gametes that this one could create. So go back to your FOIL method. Big B, big L, that will be in one of the gametes. Big B, little l will be in another gamete. Little b, big L will be in a third gamete, and little b, little l will be in the fourth gamete. So you figure out what are the gametes that this one can make and what are the gametes that this one can make. And then you would put those gametes, which has already been done for you, you would put those gametes up here on the axes. So here's one female, or here's the female, here's the male. It doesn't matter which axes you put, male, female, at all. And then you cross. So this guinea pig is going to be the result of this egg meeting this sperm. So check out what they've done. They have pulled, big B, big L, and written down right here under the little guinea pig that individual's genotype. Notice they put the B's back together and they put the L's back together so that it's easier to kind of read what that guinea pig is going to look like, putting your homologous pairs back side by side. So I want you to pause this and finish out this chart. So do the cross and bring the gametes together. So for this offspring right here, you're going to bring this egg and this sperm together. Okay, so what would go right here? Big B, big L, little l would go right here on that line. So pause the video, finish out this chart, and then I want you to count. Okay, this is the tricky part because sometimes our eyes get a little wibbly looking at all these genotypes, but I want you to count how many of these guinea pigs have black hair that is short. How many of them have black hair that is long? how many have white hair that is short, and how many have white hair that is long. And as a reminder, a little further back, here's your key. Black hair was the dominant phenotype. White hair was recessive. Short hair is actually dominant. Long hair is recessive. So take a second, pause the video, fill this out, and come back when you are ready to see the answer. Now, my encouragement to you is to actually do that. Do the practice. Don't just wait for me to progress the slide forward. Okay, so pause it, do the practice, and then come back. All right, if you're back, here is the answer set. So check yourself, check your gametes, check your genotype of your offspring. So did you get these letters correct? And then check your ratio, your phenotypic ratio. It should be 9:3:3:1. So in looking at this, if you feel good about it and you did that cross correctly, let's move forward. If something is off, correct it. Correct it right now. Okay, so flipping your paper, you have a similar type question, except some of the supports have been pulled away. So notice you have your parents up here. So step number 1, what kind of gametes can each of these parents create? So this one, and then this one. You can put the gametes in these little circles down here. So for example, this, foil it, first gamete, big B, big L. Second gamete, big B, little l. Third gamete, little b, big L. Fourth gamete, little b, little l. So there's our gametes, and then they get dropped down here onto this axis. Same thing over here for the female. What kind of gametes? Drop them onto the axis. Do the cross and count the phenotypic ratio for me again. Pause the video and do it. Really do it. I'm telling you, it will only help you as we move forward if you do these practice questions. So pause the video, come back when you're ready. All right, if you're back, here's the answer set. So check yourself. If you got it correct, move on. If you need to pause the video and correct anything, do that now. Last question set for the guinea pig. You have about the same amount of support. It's given you the genotypes of the parents, figure out the gametes, cross them together, and then give me a ratio. Pause and practice. Come back when you're ready. There's your answer set. So in this one, notice I didn't actually write all of these out because the female gametes were all the same. And so whatever this gamete and this sperm created together, all of these would look like that because all of these gametes for the female are the same as the first one. And so I just did a little shorthand arrow. That's totally fine. But there is your answer set for the last. So the guinea pigs really were designed to be a pretty heavily guided step through of a dihybrid cross. Now you have a second sheet that was given to you in class, and that looks like this. So you're going to complete this sheet front and back. It gets increasingly more difficult as you go through the question sets. By the time you get to the back of the paper, they're word problems. And so I've underlined for you as a method of support, I've underlined in the word problems, flip your paper real quick. I've underlined for you the words that describe the genotypes of the parents. So if you look at the first one, for example, I've underlined one parent is a heterozygous spotted. Okay, that tells you heterozygous for the spotted trait, and non-woolly. Non-woolly is the recessive. So you now know what the genotype of one parent is, and you'll need to write out the genotype, figure out the gametes of that parent, and put it on the chart. The other parent is a heterozygous woolly hair, non-spotted woman. So I've intentionally underlined the genotypes of mom and dad, but they're in words. So you need to put them into actual genotypes. That will be your first step. Second step is figure out your gametes and then cross them together just like we've been doing. So this sheet plus your guinea pig sheet both need to come back to class with you when you come back next. All right, so good luck and give it a go.